The Heisenberg uncertainty principle says that you can never simultaneously know the exact position and the exact speed of an object. The uncertainty principle exists because everything in the universe behaves like both a particle and a wave at the same time. Particles, by definition, exist in a single place at any instant in time. Waves, on the other hand, are disturbances spread out in space. We can clearly identify features of the wave pattern as a whole, most importantly, its wavelength, but we can't assign it a single position. It has a good probability of being in lots of different places. So if we have a pure wave, we can measure its wavelength and thus its momentum, but it has no position. We can know a particle's position very well, but it doesn't have a wavelength, so we don't know its momentum. To get a particle with both position and momentum, we need to mix the two pictures to make a graph that has waves, but only in a small area. How can we do this? By combining waves with different wavelengths, which means giving our quantum object some possibility of having different momenta. When we add two waves, we find that there are places where the peaks line up, making a bigger wave, and other places where the peaks of one fill in the valleys of the other. The result has regions where we see waves separated by regions of nothing at all. If we add a third wave, the regions where the waves cancel out get bigger, a fourth and they get bigger still, with the wavy regions becoming narrower. If we keep adding waves, we can make a wave packet with a clear wavelength in one small region. That's a quantum object with both wave and particle nature. But to accomplish this, we had to lose certainty about both position and momentum. The position isn't restricted to a single point. There's a good probability of finding it within some range of the center of the wave packet. And we made the wave packet by adding lots of waves, which means there's some probability of finding it with a momentum corresponding to any one of those. Both position and momentum are now uncertain, and the uncertainties are connected. If you want to reduce the position uncertainty by making a smaller wave packet, you need to add more waves, which means a bigger momentum uncertainty. If you want to know the momentum better, you need a bigger wave packet, which means a bigger position uncertainty. That's the Heisenberg uncertainty principle. Werner Heisenberg, back in 1927.